All right, thank you. Hi, everyone. I'm Stephen Greenstein. I'm in the math department at Montclair State University in New Jersey. And I'm here with two of our doc students, Karmen Yu and Emily Olson. And you'll just wait one moment while I remember that Karmen is supposed to have us begin. There we go. All right.
Well, thank you, everyone. Thank you for the introduction. And thank you for attending our talk. So the title of our talk is DIY Math Manipulatives for Agentive Teaching and Playful Learning. And for the guiding question of this study or this talk is, what do prospective elementary mathematics teachers learn about math, pedagogy, design, and themselves when they make original manipulatives for mathematics teaching and learning?
Okay, thank you. Great. All right. I don't know if you can see that timer or why it's there, but that's fine. So what my colleagues and doc students and I have been working on a project for 3, 4, 5 years now, where as part of the teacher preparation for future elementary teachers, they take like a specialized math content course. And we integrated this project into the course. Well aligned with an inquiry pedagogy. So we want to develop that pedagogy of mathematics for understanding. And so our hypothesis is that if we engage them in a making experience, that may lead to innovation in their thinking about mathematics teaching and learning. So what we did was we positioned teachers as designers and agents of curricular and pedagogical reform, meaning that they have some agency over the tools they use in their teaching and the curriculum that they use. And so for this project, their task is to design an original math manipulative, which is a tool for learning, like fraction blocks or pattern blocks and those kind of things. Again, it's not a researchy talk, but it may be useful to know what lenses we're using as we try to uncover all the things that they learned. Constructionism, of course. Learning by design is a way of thinking about how we can engage students in experiences that invoke an interplay between what they know and what they're designing. And Schoen has a nice way of talking about design as a reflective conversation. We can infer things about their knowledge from what they're doing as they're designing, and that contributes to our understanding of what's going into their design. Okay. That's a little bit about the design trajectory. That's the digital design lab at Montclair State. I held the class in that room to immerse them in some semblance of a design culture, even though it's just a physical culture. We taught them how to use Tinkercad, and we had in-class design sessions and in-class tutorials to help them with their designs. And then Emily is going to share, and I'll share it again later. We have a project website, a maker project website, where you can look at some of the things that they've made, that elementary teachers have made. And we're gonna share some with you as well. And you're free to look around that website, of course, as much as you want, however you want.
And we'll also be sharing a link of this presentation in the chat with you, so feel free to take a look.
Oh yes, thank you for that. This is the first of 4 vignettes, little sub-projects in our research. This is the first one that my colleague Eileen Fernandez and I did. And this is the design by a pair of future teachers working together, Casey and Mia. And they developed a tool they called Minute Minis, which combines the it integrates the abstract concept of time with these tangible representation of fractional parts. Yes, that's what they did. Right on. Okay, all right, so that's the first one. When we saw I had been playing around with 3D printers and thought they were cool, and I did the thing you're not supposed to do, which is here's a technology, let's find a problem. And so I was mucking about, as Gary said. And I brought this into the class, and Eileen, who studies teacher knowledge, was kind of blown away with all the things that they learned. And then we applied for the bigger grant to do the bigger project. So this is what we think about as our pilot study. This one called it making as a mediator of the social and conceptual dimensions of a teacher becoming. So that's a student who wanted to be called Moira. And here we're looking at how their understanding of mathematics and pedagogy and design and themselves are intertwined. There's a framework called cognition, and they're called discourses. So that's what we're looking at. How are these 4 discourses invoked in their making? And these are 4 moments on Moira's trajectory, which you can read now or some other time. But what we found is that is a very convincing case that when you're learning mathematics, you're not only learning mathematics. It is you who's learning mathematics, you who is going to be a teacher learning mathematics. And so mathematics gets intertangled in how you see yourself. And we know people generally often don't like math, or they do like math. That's an identity of itself. A math teacher is an identity. They're learning 3D design for the first time, but Moira had these very creative intentions early on in her K-12 schooling that were marginalized because math was not seen as a creative space. So the findings from this provide a convincing case that all of those ways of knowing pedagogy, design, math, and about yourself are interwoven. This is making to leverage funds of cultural knowledge. So these are two students in the class, Jessica and Maya. And Maya was from the Dominican Republic. Her first language was Spanish. And she was reserved, like not just quiet, but reserved, and gave the impression that she didn't want to bring her, not even her language, into class. But Jessica, who was familiar with this concept and also this kind of teacher, mined in a Freudian way, mined Maya's cultural knowledge. And they developed this tool that they called No Mas Caídas, which is informed by games that Maya had played back in the Dominican Republic with sand and rocks. And so No Mas Caídas means don't fall over, I'm told. And this is a picture of just doing like a problem-solving interview with Maya. So the teachers designed their manipulatives and then they tested them out. So they had to write some problems to work with to see how well they worked in an actual interview situation. And this is another vignette. One of the students, Denisha Kum, on the project is interested in, so we were interested in what knowledge, what do they learn? What do they bring to it? Denisha's take was, for all the decisions that they make when they're designing their manipulatives, why do they make them? What are their decisions and why do they make them? And what are they bringing to their design? So the tool has to be something to help somebody learn with understanding, not just like mimic a procedure. So that means it invokes an inquiry pedagogy. Well, they have to know the math as well. And these are a couple of the designs. That's Moira's fraction rings. Those are rings that are equally partitioned into halves and thirds and fourths that she used for fraction comparison and later for division. And that is Anyango's fraction pedestal. So Anyango wanted height to be a proxy for magnitude of fractions. So you can see how the fraction idea gets embedded in different ways in these tools. They interviewed their target student before they did their designing, and some of them used what they learned about that student, what they struggle with, what do they want to learn in informing their design. The role of the aesthetics, one of the Anyango, I think, had talked about she wanted them all to be the same color, because if they were different colors, then the student might say, well, the red one is half, as opposed to half is the one that's divided equally into two parts. So that gives like that gives us deeper insight into what teachers are doing as they're designing, a lot more than the final product would. And now we're gonna alternate between Emily and Karmen. These are some of the more recent math manipulatives that we want to share with you.
And the first one that we want to share with you is this star math manipulative that is designed to pair with this book, How to Catch a Star, targeted for pre-K to second grade students. And with this manipulative, students can, as you can tell from the picture on the right, students can sort the stars by colors and size. And I'll have Emily to talk about our next manipulatives for us.
Yeah, so for this next manipulative, it's called Turtle Bug. So it's a way for young learners to explore math problems, and especially for composing or decomposing numbers, teaching concepts of addition and subtraction. We have a little example in the top right corner of the slide there. If these two children have 9 total toys, how many ways can you sort them into different groupings? So how many toys each kid gets. Is designed with a lot of focus on youngest learners, and it's especially intentional that it is an animal or insect because it sparks curiosity and engagement for the students. Back to Karmen.
And our next one, it's a balance scale that students get to use, as you can tell on the one of the pictures on the left-hand side of the screen, where there's a left platform for students to place marbles to represent the whole, and then the right platform, you can see that it's divided into 2 parts. So in this case, it's to illustrate this part per whole relationship. For example, Michael has 13 cupcakes, 7 are chocolate, and how many are vanilla? So students can use the left platform to place 13 marbles to represent the whole, and then they get to place 7 chocolates on one of the portion on the right-hand side for one of the parts. And then they get to then use marbles and the nature of the balancing scales to put enough marble to represent the amount of vanilla cupcakes until the balance scale, it's nice and balanced right in the middle. And back to Emily for the next one.
So this one is the fraction waffle. It's designed to teach children about fractional parts of a whole. So as you can see, there's 16 pieces in this waffle shape. And so it's an interactive way for students to visualize how to divide a whole thing into multiple parts. So you can ask students to figure out like half of the waffle, a quarter, 1/8, 1/16. And the teacher that designed this wanted students to be able to develop this idea with this fun idea of having it be a waffle. Okay.
And the next one is a very intricate one of my favorites from the slide. It's a vertical number line where we have the teachers designed gears as part of the structure of this manipulatives, where students get to perform addition and subtraction. And this allows students to be multimodal and engaged with the action of adding and subtracting. So they get to increase and decrease the magnitude of the height of this vertical number line by rotating the handle clockwise or counterclockwise to show that motion of adding and subtracting. And our last one with Emily.
Yeah, so the last model, the last manipulative that a pre-service elementary student made was a decimal snake. So students can connect these pieces together, and within each of these pieces there are 10 division parts, and each of those can represent a unit. So if you have 10 of these pieces that can be connected, and in total you'll have 100 units, and that can allow students to represent decimals in tenths as well as hundredths places. And that is it. We want to say thank you to the Mix Lab at Montclair State University, as well as the National Science Foundation. We leave you with some questions about what do you think, what do you want to talk about? And we'll get into the Q&A in just a second. The last slide. Also just want again to note the Maker Project website. I'm sending that link again if you want to visit and get more information. And also the credit also goes to these makers, including Dr. Aline Fernandez, Jessica, I can't see what the last name is with the timer, and Aaron Pomponio and Dennis Akum. So thank you so much. And yeah.
Thank you.
Thank you. We have spare time for questions, so please.
I have a quick question. And I'll look at the website, and I'm sure you would explain this in much greater detail. Are you working with pre-service and in-service teachers? And are they the ones doing the design of the actual product? They're learning the digital fabrication as well?
Yeah, it's a course for, it's a graduate level course for prospective elementary teachers who are coming back to get certified to teach. So some of them are in classrooms. That's why we say that there's some of them are current and some are prospective. And yes, they're doing the designing, and then I'm tweaking. Like if they send me something that won't print well, then the gear one was very ambitious and I helped with that. So I am helping out, but they are learning Tinkercad and doing the bulk of that themselves at home and in class.
Hi.
Yeah, hi.
Hi, thank you so much for this. I am actually, we had a PD day. I teach at an elementary and middle school. And during our PD day today, I ran a session on intro to Tinkercad for our teachers. So this is very topical. But you know, I had 8 teachers from everyone in the school. So not everyone is, you know, knows how to use Tinkercad or knows how to, you know, do this or wants to put in the time to learn if you're already a teacher, you know. I'm wondering if like some of these manipulatives are like available, you know, the ones that your teachers or your pre-service teachers designed are available like as files that I could print to show people or to use.
Yes, there's on the website under made projects, there's STL files associated with all the ones that we have. And then there's a new CAD library that I'm a part of that is publishing manipulative. So some of them appear there as well. Some of the ones that you can email me because some of the ones that were in the presentation are not up on the website yet. And yeah, we did have to, they did learn Tinkercad. We had the time to teach them Tinkercad enough to do it.
That's awesome.
Enough for them to give me like the general idea of what they were going. Anybody else? Well, I'm
Thank
gonna
you
stop
very much.
sharing. Yes. Thank you too. Thanks, Carmen and Emily.